Good morning, guys. So last time we discussed logarithmic function, right? So if you remember, if you have an exponential function y equal to, let's say, a to the power x, right? And then you switch x and y, you interchange x and y, then you'll have x equal to what? A to the power y, right? And this y here, this y, the exponent y is the what? Logarithm with base a of x. And this is exactly the what? Logarithmic function. Logarithmic function, right? So what you need to know is, if you have x equal to a to the power y, or if you have y equal to logarithm with base a of x, so this is equivalent with what? X equal to a to the power y. Or you can simply write down, this is the same thing, logarithm with base a of x equal to y, right? So this is equivalent with x equals what? A to the power y. So this is very, very important relation, okay? So I think using this relation we can solve so many logarithmic equation, okay? So remember, this a here is the base, okay? So if you have a y equal to logarithm with base a of x, this a is the base. This, like a is the base, okay? And then y is exponent. So you need to know this. And then if you want to solve this, I think we did this equation last time, but let me try the next one, okay? Let's try this one, okay? So if you have so how do you solve this? Logarithm with base 49 cube root of 7 equal to what? X. Okay? So you have to solve this equation, okay? So remember, if you have a logarithm with base a of x equal to y, so this is equivalent, right? X equal to what? A to the power y, right? So now what do you have here? Logarithm with base 49 cube root of 7 equal to x. So now if you look here, you see in place of a you have 49, right? And in place of x, what do you have? In place of x you have cube root of 7. So write down cube root of 7 here equal to, in place of a you have a 49, so write down 49 here, and in place of y you have x, so 49 raised to the power x. That makes sense? Yeah, and then you just solve this, so what do you have here? This is same as this cube root of 7 is same as 7 raised to the power 1 over 3, right? Equals to, this 49 is 7 square raised to the power x. You know that, right? Cube root of a is 7 raised to the power 1 over 3. So if you have an nth root of a, so this is equal to a to the power 1 over n. So that's why cube root of 7 is equal to 7 to the power 1 over 3. Right? That makes sense? So now what do we have now? So we have from here, from here, we have 7 to the power 1 over 3, 7 to the power 1 over 3 equals to, and you see here the power is raised by power again, you multiply them. So that will be 7 to the power what? 2x. Makes sense. And remember the property of exponents. If you have a to the power b equal to a to the power c, so this will give you what? B equal to c. So if you have the same base here, so 7, 7, you have the same base. So that will give you 1 over 3 equal to what? 2x. Right? And then you divide both sides by 2. So what will you get? If you divide both sides by 2, you will get x equal to 1 over 6. Right? Yeah, x equal to 1 over 6. So that is the solution to the given logarithmic equation. So x equal to 1 over 6. So the solution set is, you see the solution set is 1 over 6. So this is the final answer. Good. Now we did that, right? A logarithmic function, we defined that. So if a is, let me write down that, if a is positive and a is not equal to 1 and x positive. If you have a positive, a is not equal to 1, a is not equal to 1 and x positive. So fx equal to logarithm with base a of x. So this is the logarithmic function. So this is the logarithmic function. Okay? So if you want to draw the graph of the logarithmic function, so you guys know that the logarithmic function is the inverse of exponential function. Okay? So let's say remember, if your exponential function is y equal to 2 to the power x, so this is exponential function. And the logarithmic function is, the inverse of exponential function. So you just find the inverse of this. How do you find the inverse? You interchange x and y like we did before. So that will give you x equal to what? A to the power y, right? But in this case, what is your a? This is 2 to the power y, right? And you remember, if you have a logarithm with base a of x equal to y, so this is equivalent x equal to what? A to the power y. You know that, right? So now what do you have here? X equal to 2 to the power y. X equal to 2 to the power y. So this will be equivalent in logarithmic form. It will be logarithm with, you see in place of a you have a 2 log 2x equal to what? Y. So this is the inverse function. This, if this is your fx, if this is your fx, so this f inverse x equal to logarithm with base 2 of x. So this is the inverse function of this exponential function. And remember, so if you draw the graph of exponential function y equal to 2 to the power x, if you remember from the last, from the last week class, we graphed this, okay? And remember, we got a graph like this, something like this. So this is the graph of fx equal to 2 to the power x. And then the graph of inverse is found, the graph of this inverse function is obtained by reflecting this graph across the line y equal to x. So you know this is the line y equal to x. So let me show you here. This is the line y equal to x. This is the line, right? This is the line y equal to x. And if you reflect this across the line y equal to x, you'll have a graph like this. You see? So you'll have a graph like this. You'll have a, I think like you. So this is the line y equal to x, right? So if you have a reflect this, you'll have a graph like something like this, right? This. So this is the graph of f inverse x inverse logarithmic function. This. So this is the graph of this function. So you see the exponential function and logarithmic function, they are inverse to each other. Okay, so now we got this one, right? And if you want to draw the, if you pick like a different x values and different y values, and you can draw, I think you can look at the slides, you can obviously see that, you know, like, so fx equal to log 2x, and you pick like a different values of x, you know, and then you will get the different values of y, right? For x equal to 1 over 4, the value of fx is negative 2, and for x equal to 1, the value of fx is 0, and you see, you can draw the graph, and this graph is increasing and continuous on the domain. You see, increasing and continuous on the entire domain. So this is the graph of this function, and then if you want to draw the graph, look here, the next one. Yeah, so this is the general graph, right? And this is the graph of fx equal to logarithm with base 1/2 of x. And you see this is decreasing and continuous on its entire domain. This is the graph of the logarithmic function, you know, like. So let me draw this graph, okay? So on the, look here. So if we want to draw the graph of the function fx equal to logarithm with, you know, like a base 1/2 x. So you need to find the different y values for different x values, you know. So you make a table here for x, y, and hey, if I plug you x equal to 1, so what is the value of log half of 1? So the logarithm with base 1/2 of 1, okay? So this is always 0. Logarithm of 1 is always 0. So it will be 0. And if I pick x equal to, let's say, 1/2, so what will be that is logarithm with base 1/2 of 1/2. So what will be this? Let's say you want to evaluate this. Let's say this is your, you know, like a y, right? Right? And you want to evaluate this logarithm with base 1/2 of 1/2, okay? So remember, if you have a logarithm with base a of x equal to y, if and only if, right, x equal to what? A to the power y. So this is logarithmic form, and this is equivalent exponential form. So, if you do that, look here. You have a logarithm with base 1/2 of 1/2 equal to y. You have this, right? Right? So in place of x, you have 1/2 equal to, in place of a, you also have 1/2. And in place of y, you have y. See that? Now, if you look here, you have the same base, and then you can equate the exponent. The exponents are equal, you know. Remember, if you have a to the power b equal to a to the power c, so this is equivalent with what? B equal to c. So that's why this will give you y equal to what? 1. 1 equal to y or y equal to 1. So you see, you got y equal to 1, right? So logarithm with base 1/2, logarithm with base 1/2 of 1/2 is what? Equal to 1. So you have to know this. So this is 1. Or I will write down the one property here. We will talk about, talk about that later. But look here. If you have a logarithm with base a of a to the power x, if you have this, it's always equal to what? X. That makes sense. So now, if I have a 1/4 here, if you have a 1/4 here, you can do like this to get the value, but you can use this also. We can look here. This is a logarithm with base 1/2 and 1/4. So this is same as logarithm with base 1/2. This 1/4 is 1/2 square, is that right? So remember, logarithm with base a to the power x is x. So logarithm with base 1/2, 1/2 to the power 2 is what? 2. So that's why this is 2. You got it? Now, if you want to find out the 2, if you plug in x equal to 2, then you'll have a logarithm with base 1/2 of 2. Because you plug in 2 here. Logarithm with base 1/2 of 2. And so this is going to be logarithm with base 1/2. And this 2, you see, if you look here, this 2, how do you write like this? You can consider this as a, it does not have a, let me write down here, if you understand. This 2 is same as 2 to the power 1, agree? Right? And then this is same as logarithm with base 1/2. This 2 to the power 1 is same as 1/2 to the power -1. Right? So this is same as logarithm with base 1/2. This 1/2 to the power -1 is same as 1/2 raised to the power what? -1. Right? So now, so that's why this, and you apply this. You use this, okay? So logarithm with base a to the power x is x. So logarithm with base 1/2, 1/2 to the power -1 is -1. So that's why you have what? -1 here. Right? So if you have a 4, if you apply the same here, let's say this is 4. So this is 2 square. This is 2 to the power -2. So this is 1/2 to the power -2. So this is what? -2. So this will be -2. And if you plug in 8, this will be what? -3. Now, you can draw the graph. So this is your x-axis, this is your y-axis, and you plot these points, So let's say this is your 1, 2, 3, 4, 5, 6, 7, and this is 8, okay? And then you have -1, -2, -3, and so on. So you have 1, 2, 3, -1, -2, -3. So let me plot the point 1/4, 2. So 1/4, 2, right? So 1/4 is pretty close to 0, right? So 1/4, 2. So somewhere here, right? So this is 1/4, 2. And then you have 1/2, 1. So 1/2, 1 is somewhere here, And then you have 1, 0, this. Then you have a 2, -1, this. Then you have a 4, -2, this. Then you have 8, -3 somewhere here. So now you see the graph looks like what? So the graph looks like this. So this is the graph of the function f(x) equal, this is the graph of f(x) equal to logarithm with base 1/2 of x. Right? And what is the domain here? What is the domain? The domain of every logarithmic function is 0, positive, infinity. So this is the domain. And what is the range? What is the range? Range is -infinity to positive infinity. So the range is -infinity, positive infinity. Okay? And if you look here, the graph is decreasing. This is decreasing and continuous. Okay? Make sense? So I think you can do this now, and then you can graph. We did this one, we did that. They have here. So y equal to 1/2 to the power x is exponential function, and f(x) equal to logarithm with base 1/2 of x. So that is the inverse of y equal to 1/2 to the power x. Okay? And the graph of y equal to f(x) equal to logarithm with base 1/2 of x is obtained by reflecting the graph of y equal to 1/2 raised to the power x across the line y equal to x. So similarly you can draw, okay, so this graph. So this is not that much hard, okay, you can do that, okay. So now I want to take you to the next section. So it is 4.4, I believe. Now we have two kind of, this is 4.3 or 4.4. Let me check on that, okay. So we did 4.2, right? So 4.3. I think like I skipped 4.3. 4.3, the logarithmic function. Did we talk about the properties of logarithmic function? Let me find that one, okay. Properties of logarithmic function. Okay, this one. So these are the properties of logarithmic function. So the first one is the product property. So the product property. Remember, if you have a logarithm with base a of x, y, x times y, if you have this, so this will be same as logarithm with base a of x plus logarithm with base a of y. So the logarithm of the product is sum of the logarithm. But you have to be, you see here, you have x positive, y positive, right? A positive, and a is not equal to 1. Okay, so this is product property. Did you get it? Right? And then the next one is quotient property. Logarithm with base a, x over y is same as logarithm with base a of x minus logarithm with base a of y. So this is the product property. Right? So the logarithm of the quotient of two numbers is equal to the difference between the logarithms of the number. Good? The next one is the power property. Logarithm of a number raised to a power is equal to the exponent multiplied by the logarithm of the number. And the last one is, it's not the last one. So logarithm of 1 is always equal to 0. And logarithm with base a of a is always equal to 1. So these are the properties of logarithm. Got it? So this is the product property, and if you remember, the another one is logarithm with base a x over y. It's same as logarithm with base a of x minus logarithm with base a of y. So this is the quotient property, right? And then what is the next one? Logarithm with base a x to the power r is same as r times logarithm with base a of x. This is the power property. And logarithm with base a of 1 is always equal to 0. Logarithm of 1 is always equal to 0. And the last one is logarithm with base a of a is always equal to 1. Make sense? So these are the properties of logarithm. Okay, now if you want to find out, let's say, so if you want to rewrite this using the properties of logarithm, okay? So rewrite logarithm with base 6, let's say 7 times 9, right? So you rewrite this using the properties of logarithm, okay? Using the properties of logarithm. Properties of logarithm, okay? So remember, use the product property, this property. Right? So logarithm with base a of x times y is equal to what? Logarithm with base a of x plus logarithm with base a of y. So this is same as logarithm with base 6 of 7 plus logarithm with base 6 of 9. So use product property. This. And then if you want to rewrite this, let's say logarithm with base 5 of 15 over 7. So what will be this is, you use the quotient property, okay? This property. So if you use the quotient property, it is going to be logarithm with base 5 of 15 minus logarithm with base 5 of 7. Right? Good. And then the next one is, if you want to rewrite this, okay, logarithm with base 5 is square root of 8. So rewrite this using what? Properties of logarithm. So you remember this is same as logarithm with base 5, 8 raised to the power 1/2. Is that right? The square root of 8 is same as 8 raised to the power 1/2. And now you can pull this. You can pull this 1/2. So this is same as 1/2 logarithm with base 5 of 8. So you see this is the from the power property. This property. This from here. This is the power property. This is the power property. So logarithm with base 5, the square root of 8 is same as this. That makes sense? And then it's the same here. You can use the power property. Like, let me erase this one. If you have a logarithm with base a, logarithm with base a, cube root of m square. So this is same as logarithm with base a, this cube root of m square is same as m square raised to the power 1/3. Right? And so this is same as logarithm with base a, m to the power 2 times 1/3 is 2/3. But use the power property. If you use the power property, so this is same as 2/3 logarithm with base a of m. So you can rewrite this in this form using power property. Right? Okay. And now for this one, so let me erase this. So if you have a logarithm with base a, m and q over p squared t to the power 4. So rewrite this expression using these properties, okay? So first of all, we will use the quotient property, this one. So if you use the quotient property, so it will be what? It will be logarithm with base a of m times n times q minus logarithm with base a p squared t to the power 4. So this is, like a use this quotient property, right? And then use product, this. Logarithm with base a of x times y is what? Logarithm with base a of x plus logarithm with base a of y. So you use like a product property. So it will be, now you see this property can be extended for the product of three numbers. Like if you have a logarithm with base a, x times y times j. So this is same as logarithm with base a of x plus logarithm with base a of y plus logarithm with base a of g. Right? So now here, this will be logarithm with base a of m times plus, logarithm with base a of n plus logarithm with base a of q. And then you also use product property here. This is minus, you put the parenthesis, right? So this is same as logarithm with base a of p square plus logarithm with base a of t to the power 4. You consider this as a x and this as a what? Y. So logarithm with base a of x times y is logarithm with base a of x, but your x is p square, right? So, make sense? So now you distribute this negative, okay? If you distribute this negative, what will happen? This will be negative and this will be what? Negative. Okay, so now logarithm with base a of m plus logarithm with base a of n plus logarithm with base a of q, and now you the power property, this one, power property, okay? So now it will be minus 2 times logarithm with base a of p minus, this is 4 times logarithm with base a of t. You know the power property, right? That one, okay. So now this is the final answer. Okay? So this is that. Okay, that you can do that one. And then you can rewrite the given expression using these properties, right, as a single logarithm. So you write each expression, as a single logarithm. Single logarithm with coefficient 1. With coefficient 1, okay? So now we have this. Logarithm with base 3 of x plus 2 plus logarithm with base 3 of x, right? And minus logarithm with base 3 of 2. So you have to write down this expression as a single logarithm. Okay? So use the product property here. Look here. If you have a logarithm with base a of x plus logarithm with base a of y, you will have logarithm with base a x times y. So use this property. So it will be logarithm with base 3 x plus 2 times x. This one, right? Use this property. Minus logarithm with base 3, 2. That makes sense? So then use this property, quotient property. If you have a logarithm with base a of x minus logarithm with base a of y, so they should be logarithm with base a of x over y. So that will be what? Logarithm with base 3 x plus 2 times x over what? 2. That makes sense? You see? You write this, we wrote down this expression ij single logarithm. Make sense? Okay. And you can do, like, let's say, okay, here. If you have a 2 times logarithm with base a of m minus 3 times logarithm with base a of n. If you have this. So use power property. If you use the power property, it will be logarithm with base a m to the power 2. Use the power property, okay? In this direction. Are you guys with me? And then here, you also use the power property. So this is logarithm with base a n to the power what? 3. Right? And now, use the quotient property, okay? So if you have a logarithm with base a of x minus logarithm with base a of y, it will be equal to logarithm with base a x over y. So this is going to be logarithm with base a m square over what? N cube. Make sense? So you wrote down single logarithm. I think that's the all about properties of logarithm. And I want to take you to the next section, okay? So common logarithm, we will discuss common logarithm, natural logarithm, and their applications, okay? So common logarithm, you know, if you have a base 10, log with base 10 is the what? Common logarithm. So common logarithm. So you know fx equal to logarithm with base a of x, right? Right? X positive and a is not equal to 1, something like that, right? So if you replace this a by 10, if the base is 10, then you will have fx equal to logarithm with base 10 of x. Right? So this log 10s, you simply write down log x. So this is the common logarithm. Does that make sense? Yes? So this is the common logarithm. So now in your calculator, in your calculator you can find a tab, you can find a key, like a tab to find the to evaluate the common logarithm. A calculator with a log key can be used to find the base 10 logarithm of any positive number. Base 10 logarithm is common logarithm, okay? Yeah. Then you can just use your calculator to evaluate, to evaluate log 1000, log 42, log 0.005832. You just use calculator to evaluate those values. You can do that using calculator, okay? So now let's talk about the application, okay? So now this pH of a solution is defined by using this formula. The pH is negative log of hydronium ion concentration in moles per liter. Okay? And if the pH is less than 7, then the solution is alkaline. And if the pH is if the pH is greater than 7, I'm sorry, okay. If the pH is greater than 7, the solution is alkaline. And if pH is less than 7, the solution is acidic, right? That makes sense? Okay. And if it is equal to 7, what do we have? Neutral. The water has pH 7. So what you need to know is this pH is defined as negative of logarithm of H3O plus. So the H3O plus is the hydronium ion concentration, and you just need to know if pH is greater than 7. So this means alkaline substance or alkaline solution. If pH is equal to 7, I think this is neutral, and generally pure water is neutral. And if pH is less than 7, so this solution is what? Acidic. Make sense? Yes? So this is what you need to know, okay? So you need to find out the pH of a solution with H3O plus concentration. So we need to find this. So how would you find this? So you need to find the pH of a solution with H3O plus equal to 2.5 times 10 to the power negative 4. So remember the definition, okay? So pH is what? Negative logarithm of H3O plus, right? So we have H3O plus. H3O plus is given. So this is 2.5 times 10 to the power what? Negative 4. So we plug in the value of H3O plus, so this equal to negative log times 2.5 times 10 to the power what? Negative 4. And use the calculator, guys. You can use the calculator to find this, okay? So figure out the value of, you can use the properties of logarithm. You know the logarithm of the product is the sum of the logarithms, right? So this is same as logarithm of 2.5 plus logarithm of 10 to the power what? Negative 4. So this is negative, so this is log 2.5, and you can use the power property if you like. So this is negative 4 times what? Log 10. Okay? And the value of log 10 is 1. Remember, this log with base A of A equal to what? 1. And this log 10 is same as log with base 10 of 10. So this is equal to 1. Or you can use calculator, guys. You can use calculator, okay? So now this is negative logarithm of 2.5 and minus 4, right? Because log 10 is 1, negative 4 times 1 is this. Make sense, guys? Yes? And then you just like use calculator. What is log 2.5? What is log 2.5? Can you find that? So log 2.5 minus 4. Can you find that, log 2.5? Yeah, this is log 2.5 is 0.397940, something like that, right? And you subtract 4. Yep, so this is negative 3.6, so you multiply by negative, so you will have a positive number. Is that right? What did you get? I got 3.602059991. Okay? Yeah. So, and you see the pH is less than 7 here, right? So solution is acidic here, right? Let me find out. Yeah, it's approximately equal to 3.6. pH is approximately equal to, so this is approximately equal to what, 3.6. Are you guys with me? Does that make sense? Okay, good. So now look here, find the hydronium ion concentration of a solution with pH equal to 7.1, right? Your pH is 7.1 and you need to find the hydronium ion concentration of a solution. So use the same formula. So let me look at this. So what is the pH? 7.1. This is given, right? And what do you need to find? So given pH equal to 7.1, and you need to find out this H3O plus equal to what? So pH is 7.1 minus logarithm of this is hydronium ion concentration, okay? Makes sense. So you multiply both sides by negative. So this is same as negative 7.1 equal to logarithm with, you know, like it's the logarithm of hydronium ion concentration. And this is same, this is equivalent with logarithm with S3O plus equal to negative 7.1. Right? Are you with me? So, okay. Now, remember guys, if you have a logarithm with base a of x equal to y, so this is equivalent with x equal to what? A to the power y. This is the logarithmic form, and this is an equivalent exponential form, right? What do you have there? You have a logarithm of hydronium ion concentration, this equal to negative 7.1, is that right? So this is equivalent with, now look here guys, now in place of x, what do you have? S3O plus. So you write down here S3O plus, right? You write down here this. And in place of A, now this is the common log. This is the common log. So remember that it has the base 10. Common log has the base 10. Logarithm with base 10 is the common log. Okay? So now H3O plus equal to 10 to the power negative 7.1. Remember that? A is 10, A is 10, A is 10, and your Y is negative 7.1. And you are supposed to find the value of what? Hydronium ion concentration, right? So you just use the calculator. So 10 to the power negative 7.1. So you can write down this as 10 to the power negative 7.1 is equal to, what did you get guys? I got, so this H3O plus equals to 7.943282347 times 10 to the power negative 8. I got this one. And this is equivalent to 8 times 10 to the power negative 8. Right? Yeah, or if you round to one decimal place, this is 7.9, okay? If you round to one decimal place, this is 7.9. You can just write 7.9 times 10 to the power negative 8. Make sense? Yeah. So this is the This is the value of the S3O plus. Okay. Yeah. We got this one. And if you want to do, so the loudness of intensity, right? We measure the loudness of the sound, sorry. The loudness of the sound is, you see, if you look at the slides, you can see that. So this is defined, it's measured in decibels, right? And D equals to 10 times log I over I sub 0. You know, like, so you just need to find the decibel rating D of a sound with intensity. 10,000 times I sub 0. Okay? So you just simply use, you know, like the given formula to evaluate the what? Decibel. Okay? Are you with me, guys? So the decibel rating D of the louder sound is given by the following formula. D equal to 10 times log I over I0. Find the decibel rating D of the sound with intensity 10,000 I sub 0. So I is intensity. Okay? So look here. So the decibel, you know, is given by 10 log intensity over what? I sub 0 this. This is the formula. And what you need to do here, you have to find D equal to what? When the sound with intensity. When sound with intensity, I is 10,000 I sub 0. Okay? You have to find the value of D when I equal to 10,000 I sub 0. Makes sense? So you just find out, you just plug in I equal to what? 10,000 I sub 0. This is 10 log. So this is 10,000 I sub 0 divided by what? I sub 0. Simple. Right? And then this I sub 0 and I sub 0, you cross them out, you cancel them. So that will give you D equal to 10 log what? 10,000. Right? And if you use you can use the calculator. If you use calculator, log 10,000 is, I believe, what? This is 4. Is that right? So this is 10 times 4. This is 4. Use calculator, guys. Look. You can use calculator. So that will give you what? 10 times 4 is what? 40. So the decibel rating D of his sound is what? 40. Right? 40. Make sense? Are you with me, guys? Yeah. So the next one is the natural logarithm. And we written that at lnx, natural logarithm, okay? So if, look here, for x positive and a is not equal to 1, your logarithmic function is this. You know that, right? Right? You replace, if you replace this base a by e, replace a with e. So this e is the exponential number. E is the exponential number. If you replace a with e, then you will have f(x) equal to logarithm with base e of x. Good? Right? And this is denoted by L. This is L. N, maybe like a natural log, L stands for log and N for natural log x. So this is the natural logarithm. So this is the natural logarithm. Make sense, guys? So if you replace base a by 10, that will be common logarithm. If you replace base a by e, replacement of a with e gives you natural logarithm, right? And then remember that, so you have if you have a logarithm with base a of x equal to y, so this is equivalent with x equal to e to the power y, right? So here, this ln x is same as logarithm with base e of x equal to y, because it's the same, is equivalent with x equal to, in place of a you have e, so e to the power y. X equals to e to the power y. Did you get it? Okay, so this is natural log. We did that one, right? And use the calculator, to find those values. You can do that. Just use calculator, okay? You can do this one. Okay? And let me write down the one thing here. ln e to the power x is always equal to x. If you have ln e to the power x, because this is same as logarithm with base e to the power x. This is what? If you use the power property, you can pull out this x. So then you have a logarithm with base e of e, is that right? And if you have a logarithm with base a of a, remember this is the property with, this is 1, right? We know that, right? So now, this is just x, because this is 1, x times 1 is what? X. Got it? Did you? Good, guys. So that's why if you want to evaluate ln e to the power 3, it's going to be 3. ln e to the power 5, it will be 5. It will be 5, okay? Good. Okay. Yeah. And I think you can do this, and I want to take you to the next section. This is 4.5. Right. Yeah. 4.4. Maybe we let me talk one thing from the open. The change of base theorem. So the change of base theorem is, I think somewhere here I want to show you. So this is the change of base theorem, For any positive real number x, a and b, where a is not equal to 1, b is not equal to 1, then the change of base theorem tells you this, okay? So if you have a logarithm with base a of x, this is equivalent with logarithm with base b of x over logarithm with base b of a. So this is the change of base theorem. And you need to know that this x positive here, a positive, right? B positive, a is not equal to 1, b is not equal to 1. So this is the change of base theorem. Let me write down here, change of base theorem. Change of base theorem. Logarithm with base a of x equal to logarithm with base b of x over logarithm with base b of a. So this is the change of base theorem. You got it? So now if you want to find out, let's say, if you want to find a logarithm with base 5 of 17, so this is same as you can pick logarithm with, let's say, base e. So you can write down, or you can simply write down log 17 over what? Because base 10, let's say this is logarithm with base 10 of 17, logarithm of base 10 of what? 5. This is from the change of base theorem, right? And that is equivalent to log 17 over log 5. So what is log 17 over log 5? You just use the calculator. So log 17 over log 5. Log 17 divided by log 5. Yeah. So this will be 1.7604. Okay? So this will be equivalent with 1.7604. Or you can use, you can use logarithm with base 5 of 17. In a change of base theorem, you can change, let's say the base is e. Okay, logarithm with base e of 17 over logarithm with base e of 5. Same thing, right? But you need to know that this is the natural log. So this is ln 17 over ln 5. And it will also give you the what? Same answer, 1.7604. Make sense? It's the same thing. So this is what the change of base theorem. So you can do this, and you can do the same thing here. Logarithm with base 2 of 0.1 is same as log 0.1 over log 2. And use the calculator. And then you evaluate that one. Okay? Does that make sense, guys? Now here we will talk about the exponential equation, okay, how you solve exponential equation. Now first of all, so this property of logarithm is very important, okay, so you need to know that. If x positive, y positive, a positive, and a is not equal to 1, and if you have x equal to y, that is equivalent with logarithm with base a of x equal to logarithm with base a of y. So basically, if you have an equation, you can take log on both sides. If you have a x equal to y, right? If you have a x equal to y, you can write down logarithm with base a of x equal to logarithm with base a of y. So this is so important, x equal to y. So you can take log on both sides. So logarithm with base a of x equal to logarithm with base a of y. So this is important. Okay? So now if you want to solve this equation, okay, solve 7 to the power x equal to 12. So you want to solve 7 to the power x equal to what? 12. So you cannot make the same base on both sides. You cannot. Right? This is an exponential equation. You cannot make the same base. Look here. If you have a 3 to the power x equal to 9, right? You don't have to, you can take log on both sides, but you don't have to, because you can make the same base on both sides. So this is 3 to the power x. This 9 is what? 3 square. Right? And remember, if you have a to the power b equal to a to the power c, so this is equivalent with what? B equal to c. Make sense? So that means your x is equal to what? 2. Right? But here, you cannot make base same on both sides. So that's why you have to take log on both sides. You can take common log or natural log, it's up to you. If you want to take natural log, it will going to be ln 7 to the power x equal to what? ln 12. Using this. That makes sense? So now remember the power property. And you guys know that, right? This ln means, hey, don't get confused here. This is same as logarithm with base e. You know that, right? You know that, right? This is same as logarithm with base e. So you have ln 7 to the power x equal to ln what? 12. Right? So you have the power property. If you use the power property, it will be x times ln 7 equal to what? ln 12. And then you divide both sides by what? ln 7, because you need to find the value of x, right? So you do ln 7 over ln 7. So you cross them out. Now use the calculator to find the value of x, okay? So ln 12 over ln 7. So ln 12 divided by ln 7. Okay. So that will give you 4.835. If you round to 2 decimal places, this is 4.84. Yeah, this is the answer. Did you get it? Make sense? So this is this one, okay? Yep. What? ln 12 or ln 7? Hey, can you use the calculator? Maybe I made a. So you have to pick ln, say ln 12 over ln 7, right? So what is that is? Oh, I multiplied. I multiplied them. So this is, if you do ln 12 divide by ln 7, so that will give you 1.27. So 1.28, 1.277, if you know, 1.277, okay? Did you get it? And then, similarly, you can, right here also, you can do the same thing. You can take ln on both sides, look here. Yeah, they take ln on both sides and use the power property. You see, if you use the power property, you can pull 2x minus 1 outside ln, right? So 2x minus 1 times ln 3 equal to, you also use the power property on the right side. You have exponent x plus 2. You can pull that outside of ln, right? Okay, so now and you can solve this and get the what value of x. I want to stop here. I will see you next week, Tuesday. Bye.